So before we actually do the maximizing, there's a really important data point. So it's important for our effectiveness and understanding. And kind of we missed it just because it was so, I guess, so easy, right? But theta equals 0. Okay, so when theta equals 0, it really should take 250 over 4 seconds. So it should take over 4 meters per. So it should be like 62.5 seconds. So that's 125 over 2. When theta equals 0, this is just 2000 divided by 15 meters per second, or it's 400 divided by 3, which is like 133, right? So again, it takes about 60 seconds more, right? So so if you didn't even do anything fancy and just ran straight down, you would still have a minute advantage before the bus. Okay, so now all we have to do, and so remember theta, it has to be between 90 degrees and it could be 0. Okay, but it actually can't be 0 now because we know there's some other values that you can wait more than 60 seconds. Okay. No, actually, what was the time? But I think it was more. Anyway, so B minus C equals 400 plus 50 tan theta over 3 minus 125 over 2 cosine theta. Okay, and then to maximize the theta, you can, I guess, first, I think there are always opportunities to have shortcuts, okay? So your instinct is to just carry out the calculus procedure. You differentiate it with respect to theta, okay? And then you set it to 0, okay? But before you do that, you might want to see if it's like something really obvious you missed. And you probably, there won't be because of the examples we did, but like, for example, this is bigger when theta is bigger, right? Tan increases with theta. Okay. And well, cosine, when it's acute, it actually decreases with theta. So cosine is kind of like this, right? So it goes to 0 when cosine theta is 90, and it starts at 1 when theta is 0. Okay, so they're always positive. So this number is getting smaller as theta is getting smaller, but then this whole number is getting bigger. Okay, and it's bigger and it's being subtracted. So these two kind of are they're sort of opposing each other. So then you might need some calculus to figure out if they're all like, if this was actually making it going bigger and you're subtracting something less, then we just make theta as big as possible, right? And that would be simple. We didn't have to use any calculus. Okay, so calculus is very routine. Okay, you just need to know the differentiation rules. So when you subtract two things, you can just differentiate them separately. And when you have a constant, it just differentiates to 0. So it's the same as differentiating 50 tan theta over 3. Or it's the same as differentiating 50 over 3 and then differentiating tan theta. Okay. Minus 125 over 2. And then you're differentiating 1 over cos theta. Okay, so and if you know how to do these two things, you should be able to get the derivative. Okay, and it's a similar principle to get both. And then once you got them, you set it to 0, and then you find the possible maximum minimums, and then you have to test for which one's a maximum minimum. Okay, so that's something. Actually, I'm assuming you're actually already able to do if you're doing this question. Okay, but I'll deal with it like more directly.